Okay, guys. So I believe we're good to go. If anyone is experiencing any broadcasting issues like sound issues, whatever, uh, try instead of using microphone, try calling in the numbers provided in the email I sent. So that would be other alternative. Unfortunately, I cannot have you on, so you cannot talk so that I could hear you because of the echo and etc. In the very end of this session, I will open up a question and answer field, so please use chat window for that as well. So now I see that. Hide the webcams. I don't need any webcams here. Yeah. So let's begin. So session summary. Again, most of you should already know what you subscribed for, which webinar you're attending, but just in case, during this webinar, you will explore alternative workflows. And by saying workflows, I mean how to get from AutoCAD to Robot, how to get from Revit to Robot, and etc. Not starting your model in Robot and doing all of the modeling in Robot from scratch. So additional functionalities you have there. So learning objectives. So in the end of the session, what should you be able to? So when it concerns AutoCAD and Robot, import live AutoCAD drawings as XREF as a background. Reuse AutoCAD data that you already have from the model. For example, if you have some kind of a central lines of a steel structure, for example, you could import just the central lines and assign profiles to that. So we'll go through this. Revit Robot part. So you should be able in the end to understand the analytical model in Revit and describe the integration between Revit and Robot in detail, so what is happening there. And we'll talk a little bit about extensions, which additional extensions you have there, which can help you to generate the model. So starting from AutoCAD to Robot, that will be our first part. And importing live AutoCAD drawings as a background and reusing AutoCAD data. So the demonstration will be live, not a PowerPoint. So let's go there. I will start up Robot now. And in general, just choose a new project. As you know, this kind of a project view, building design, was introduced a few years ago. Most of the old users, not age old, but the ones having more experience with Robot, most of you are used to this one, which is called shell design, which is the most complete mode, which you have everything. So this one is relatively new. And this is actually a very nice way of modeling in Robot. If you don't have any data like Revit Model or anything, you can basically start here in this building design. And it works in a way like Revit does. So you have a plan views and then you have a general view. So basically in the plan views, you're able to model elements. For example, like columns. If I would draw a column, it would be just one point which I specify, and then you say, is it going upwards or downwards, and what is the height? So basically, you're standing in a plan and you're modeling by drawing walls and columns and everything. Again, you can start modeling from scratch here, what most of the people do, but as well you can utilize the data you have. So taking AutoCAD files, most of the in most of the cases when you start analysis, you'll already have a structure defined. So if I would go to File and Import, you will see that you have an option which is called DXF and DWG backgrounds. So that's basically XREF in AutoCAD, I can call it that way. Of course, it's not the full data. You don't have a texts and other things. You just basically get lines. But again, this is very helpful. So if I would use this one, and if I would move now to, for example, one of my plan views, so I have prepared several files like XY plan. Click on open here. So of course, first thing you need to look at is which units you're importing. So basically, if I will be importing meters, this is what I will get. I will have some thousands of meters, so basically kilometers. So probably I should switch back to millimeters. Try clicking apply, and then I have something more realistic. So now I see that this is a meter scale because this is my settings which I have defined. So always you have a scale factor as a possibility, so you can scale your model when you import it and after you import it. And you have some control over layers, which layers should be imported, which you don't need, which you want, and etc. So basically you have quite good control here. So if I say in this case, okay, so that my structure will be created and placed somewhere, of course I can specify insertion point as well. So if I zoom into it, you will see that it's quite detailed with all of the doors and etc. So basically, again, that's not a well-prepared file. I shouldn't have doors. I should basically focus on just the superstructure. So if I want to modify it in a way, I can always click on it and the backgrounds, and you will see a properties where you can define some data. For example, insertion point, you can click on it. Here on the blue part, always the blue part indicates the part which can be changed. And then you can respecify the data, for example, in which plan it is, or for example, the scale of it. So let's add something more. I will move now to a view to have a three-dimensional view. So switching from the plan, file, import, DWG, and for example, section BB. Saying open that one. One more time, millimeters. In order to update the changes, I would click on apply. And then you see that it's again flat because most of the times in AutoCAD you draw just everything in one plan. So I can specify here other plane, for example, YZ, and specify the location, for example, where this section should be placed. So let's say somewhere here, for example. Apply, and okay. So you see you have some kind of information now. One plan, one section, you can add more facades and so on in order to make it more sort of understandable as a data. You can change the colors of these, for example, to something more different that you could clearly see what is plan, what is a section. And you can basically start modeling your structure. What I would always recommend for you is to create axes or grids. If you would move to the plan now, you see that I have possibility to stand somewhere. So basically it has two stories defined as the default ones if I haven't defined anything else. And navigating through this is quite tricky because I cannot just go here and specify where should I go. So basically I would need to use other dialog box by clicking on the global axis, where I need to specify, for example, in which height I want to stand, like, I don't know, 3 meters, enter, and then I jump to that plane, and etc. So that's one way of doing it. But if you have grids, then you have possibility to utilize all of the grids automatically. So basically, if I would go here, for example, and say that Z direction, I don't want to use any stories. I will use grids from 0 every, for example, 3 floors. Every of the floors should be 4 meters high. Saying add, apply and close. Of course, I should have X and Y direction grids. But let's say I'm just doing it plain simple now, adding just Z direction. So then you will see that you have additional grids now. So I have a base grid, I have other grids, and etc. So through these grids I can actually navigate now. So if I move to one of the levels now, which is story 1, and let's say if I would start adding my columns, going downwards 5 meters, let's select concrete column, for example, section like this, a default section. I could basically start modeling straight away by, okay, that was a bad snapping. Anyway, this is just an example. This is beauty of it. So start modeling elements. Again, specifying, for example, some kind of beams and placing them in the model. Again, working with the plan views. The same thing when it comes to walls. For example, now I'm modeling without any snap to the existing model, and for example, some kind of a slab somewhere. So let's finish this. And if I go to the view, you will see that you have a real three-dimensional structure here. One of the things which you should be how do you say, worried about or should be careful about is actually snapping to AutoCAD file. Because by default, you can do that. By default, you can snap to it. That might be dangerous because in many cases, again, in AutoCAD, you have this sort of a floating comma. So you might have 10 numbers after the comma. I think Robot is capable to import uh, I don't remember that exactly, but I think it was something like 8 numbers after the comma when you import from AutoCAD. So it might get a really unprecise data, let's say, and Robot doesn't do roundup itself. So it might be that you're joining two walls and it looks like fine for you, but actually if you will be snapping to AutoCAD model, you might have some problems there. So again, one more time, what I would recommend is actually creating grids first. And then once you have these grids defined, go to the snap settings, which you have in Robot, and say that you don't want to select to everything. For example, you don't want to select to objects. Don't use the data which I have here in this model, all of the lines, some kind of a leaders and etc. Clean it up, leave just load-bearing elements, leave just central lines of it and etc. So that the data would be as clear as possible and as usable as possible. So if I go back here and if I select, for example, all files, I think I had one of those already pre-prepared. In this case, what I'm showing again, it kind of can track the changes. For example, previously, I had all of my links placed somewhere on the desktop, and then I moved the folder. And as long as the sort of hierarchy is the same, as long as, for example, all of my AutoCAD files in the same folder where the robot file is, all of the files which have been linked, it remembers the path automatically and sort of rearranges. So it automatically regenerates the whole model. So again, that was some plans, that was several stores, and again, no model created here in this case, just linked several AutoCAD elements, sections, and etc., which gives you additional information. Again, if you want to use AutoCAD data in other way, for example, instead of having it just as a link to which you can snap, you might do other thing is actually you can open the AutoCAD files. So when you click on open, you have possibility to choose which format you want to open. So basically Robot doesn't have some kind of a import possibilities. It has open possibility where you specify which format you want to use. One more time, in most of the cases, it's better to use DXF format because it's more readable. Let's call it that way. I have struggled sometimes with some specific DWG files that you cannot just open it. You try, but it's not working. So try just saving AutoCAD file with DXF, and that should solve all of the problems. So in this case, I have DWGs. And again, I can select, for example, some kind of a section here, saying please open that. And now I'm opening. I'm not linking it in, but I'm opening the file. So basically you have several options here in this menu where you want to say, okay, how do you want to open objects? For example, I want to say that please explode all of the objects into the bars automatically. And if I would click on OK here, one more dialog box will be open. Again, as in AutoCAD, I had a flat file that always snaps to the YZ axis. But then in this import dialog, you have possibility to use alpha, beta, and gamma angles. So if I specify an angle, for example, for beta, that was the wrong one, maybe gamma. That was the one. I should be able to easily flip it. I can specify the start axis, and then in the end I believe I need to specify that this is a scale by 0.001 so that it's not meters but millimeters. Clicking on OK, and searching for the model, and here you have it. So the section was imported, but in this case you will see that it's actually not a link, but it's something else. It has all of the bars and nodes. So again, one more time, be concerned about data and what exactly you import. So you might have, like I have now, already 14,000 elements. So that's not something you want. But again, for example, let's say if I would have a central axis of these columns, I could easily make structural elements out of them because it's already bar. What I just need to do is I need to specify, for example, a section size. We'll enable the sections, and once I click on the element, list of the elements, for example, I can select several at once. These elements will be generated as the structural elements. Again, if I would have a plan here opened, having these bars, it's quite easy to create a whole floor plan, because what I can do is once I've created all of my beams, so the same analogy as I would use for the columns. Let me just jump to a view. I will just show it theoretically. So once I have some kind of a beams created, and if these beams are forming a closed regions like this, I don't actually need even to generate a contours in order to define a slab. What you can do is actually you can click inside of the elements. Oh, jumped out of it. Click inside of the elements, so in between your beams, and it will automatically generate a slab for you, so sort of detecting the contour automatically. So that's again quite nice functionality. So getting back to the message, again, I repeated it several times. I want to do it once more. The biggest concern that I would have when I use AutoCAD in the workflow is actually the accuracy, that AutoCAD is too accurate. So before importing any links or actual data from AutoCAD, you always need to clear it up. You need to check the nodes. You need to be sure that you don't have some inaccuracies. Even though if you have some inaccuracies in your model, there is a really nice function which you can use, and you can find it here under Edit, Detail Correct. And if you will have your structure axis created, you have possibility to say that you want to correct your structure to structure axis, specifying the precision. So for example, saying 1 centimeter. So basically what it will do, it will check the whole structure, and it will see if any of the elements are actually offsetted from the axis. So for example, having a little bit offset of a few millimeters, it will automatically snap it to the axis. So align it where it needs to be, close the small gaps, and it will automatically highlight which elements have been modified. So basically you will have control, you will be able to modify your elements. Other thing is again how to understand if you have some kind of inaccuracies. Easy way would be selecting the element, right clicking on it, for example like a slab, and going into object properties. So first of all you will see the meshing settings, I don't need those, but then I can move to a geometry part, and in this geometry part I can open this small table where you can see all of the coordinates. So basically if I would go to the, before doing that, if I would go to the settings, and if I would say for example that units, dimensions, and yeah, the main structure dimensions should be in meters, but let's say should be more accurate. If I would do something like that, then you will see all of the coordinates specified here. So for example, if you will see that some of the Z values, like I do have here, are different, but usually it should be like something after the comma. You know that the coordinate is wrong, so you can easily just override it by selecting the element and just retyping the other coordinate which you want. So again, but this is a kind of a nice way of seeing which elements are slightly offsetted and etc. From where it should be. So, but that's pretty much it about the CAD and robot integration. One more thing is that you can always export your model from from Robot to the CAD, to AutoCAD file. If you go to File and if you go to Save As, again, no export procedure, simple Save As. You can specify, for example, which format, DXF, DXF or DWG format you want to use. And just be aware of one thing is actually when you export your file, it actually exports exactly what you see on the screen. So if I would enable some kind of, I don't know, descriptions, it will export descriptions. If I'll enable some reaction forces, it will export that, node numbers as well. And if you have a sections, for example, visible as a 3D elements, it will export it as a 3D element. While if you select just bars, like I have here now, only bars will be selected. So basically what you have in the screen, that will be selected during the export. So that's pretty much about the AutoCAD files. Again, the questions you have, I will take it in the end. So now I will move a little bit further to the next step, which is Revit Robot integration. This will be the most extensive actually topic because I believe this link is basically something you should use. So that's the best option you have. And when talking about it, we will talk about understanding the analytical model in Revit and integration between Revit and Robot. So basically I split it up a bit and detail it a little bit more. So when we will talk about the analytical model, we will talk about enhancements in recent releases. So what was improved since previous releases, and actually it's quite a bit. Adjusting the analytical model. So again, which possibilities you have to adjust the model, what you can do with it. I'll talk about hosted analytical nodes. That's really nice feature. In some cases, it really solves some problems. Loads and combinations, a little bit about that. Boundary conditions and settings and checks. So basically, where can you do the checks of your analytical model? Is it correct, and etc. So again, let's take a look at that. Opening now Revit model. So in this Revit model, I have a standard elements. In general, I use this during the trainings of sort of understanding the analytical model, how it works. So I have several examples, most common issues you have in your model. So I will start with this one. I will just show it in the 3D view first a little bit. So I will be jumping in between the 3D view and back. So what I have here is actually curved elements. If you have curved elements, jumping back to this level, like this, what will happen when you send it to Robot? The good thing is actually that it sends the element to Robot. The bad thing is sort of how it sends it, because if you don't specify anything else, your element will be sent. Still, it will be broke down to the straight element. So basically, node, and the straight line in between. But then, if you don't specify anything, you don't have basically control how detailed it will be. So sort of how long the lines will be. So if you will have a curved element which is breaking down to thousands of small elements, and then you have a slab on top, the slab finite element mesh size will be really dense in this combination because it will try to snap to every node. So that's something you really want to avoid. And you have this possibilities to avoid it in Revit. When you select the analytical model, you have a possibility to move to the part of the properties which is called approximate, where you can specify what is the maximum distance. So in this case, for example, 300. So this is the maximum distance from the center of the actual physical model to the central line. And you have possibility to use hard points, for example, where you have element which is joining it, saying that please break the element there so that they have a connection, and then again specifying it with more accuracy and so on. So you have possibility to control to which straight finite elements, to how many of those and how detailed it will be done. What you will probably notice again in 2013 compared to the previous versions, that now the analytical model is actually as a separate element. It has a separate properties. Earlier, when you selected, for example, a beam, you would find analytical properties somewhere in the bottom of it. Well, now when you select an element, you can basically just jump here and switch to the analytical part of it, which has its separate properties. And as well, I can select just analytical properties here straight in the model. Jumping out of this approximation, having a straight elements. One thing I said I will mention is actually hosted elements, and this is a really nice feature. Again, I will move into details about it a little bit later, but together with all of the modifications you can do with elements just using properties, in most of the cases this is what you would like to do actually without going and messing with the analytical model. You would probably go to the properties and modify the analytical model there without actually dragging and dropping it. But in cases when you want really to do more modification in more faster way, more robust way, or there is something specific that you really need to fix, which you cannot fix through properties, then you can go to Analyze tab, and you have a feature which is called Analytical Adjust. And again, when you click on it, you will see that all of the elements, they have nodes. So basically that was the biggest improvement in 2012 release, that now you have actually nodes, and you have these nodes for slabs as well. So basically you can just drag and drop the elements by selecting them. So if you click on the element, you will see that you have possibility to drag it, and then you have several options. Maybe I'll show it that way. Selecting the element. I have possibility to use the local axis, and if I hit the spacebar, I can use the global axis. So it basically jumps in between the global and local axis position. So where I can specify, for example, if it's local axis, I can just click on this red part, which identifies the axis, and I can drag it. So then I know that I'm not offsetting the element out of the plane anywhere. I'm just dragging it where I want. One more nice thing which is there is actually that you can use align tools to align the element. So basically, if I would say, please align it to this analytical model, I can do that. So it automatically will align the element to the analytical model. But there is one more feature which I wanted to talk about. That was this hosted nodes. So what you can do is basically I can select the node, and in general all of the nodes, they're actually as a big black dots. But once I have the node selected, you will see that I have option here on top which is called pick new host. So basically I can select a new host for it, and it can be a surface of the existing element, or for example analytical line. So preferably it should be analytical line. So when I click on this analytical line, actually I missed now. It's the surface of the beam, pick new host, analytical line, now I have it. Once I have clicked on this analytical line, you will see that you have a little bit more properties. So first of all, you will see that the node is actually, I will jump back to my top view, that the node is actually smaller. So then it means it sort of indicates that this is a hosted element. So when I select it, I can actually even click on the bottom, which is called show host, so that I know which element is hosting it. And then in the properties, you will see a really neat features. For example, you can go to normalized segment length, and I can say that I want to have my analytical line always in 0.5, which needs to be 0.5, of course, 0.5. And that will jump automatically to the midpoint of this arc. And if I would modify my arc in a way, making it longer, shorter, it will always follow the setting which is there. So again, it's in some cases you really want to select several offsets with the equal distance. That is very helpful. Or in some other cases, for example, I have a hard time when I need to specify all of the elements into one node. So then it would be just simply selecting that node, hosting it to the element, and saying, please go to the 0 point. So then I'm 100% sure that this element will be always at the start of the element. So basically that the nodes will be exactly at the same point, so no gap will be there in between. So again, really nice functionality which you can utilize. We will go back to this analytical adjust slightly later now. So I'm just going through the rest of the examples. So jumping back to the 3D view. And here we have, again, quite a typical situation, for example, that you have a wall and then you have a other wall which is thicker, and then what happens in between there. So if I will use a thin line mode here, you will see that they have a gap there. By selecting the element, I can say where it should be aligned. So for example, please use auto detect, and then the element will jump to its position where it sort of should be. Always this auto detect if I have specified something manually, for example, if for this one I would specify that it needs to be in the center, and if the other one is auto detect, the auto detect will always jump to the manual selection. So if you have anywhere projection and the other elements are auto detect, they will always follow to the manual specified projection. So basically it has a higher hierarchy. A little bit more. For example, with this wall again, you will see that analytical lines, again, it's something like inside of Revit, saying that if the angle between the walls is really small, maybe it's actually wise to maintain the straight line. Maybe it's not important to break it down. So again, if I would select this wall and if I would switch to a bigger angle, come on, let's try it a little bit bigger then. Maybe one more. 5, for example, 175. Then you see that it automatically adjusts itself. But if you have a smaller angle, again, it's usually going as a straight one. So what you can do is, again, selecting this element, and in this case you do selecting the analytical line, and in this case you do it the other way around. Instead of saying auto detect, you specify projection, and in this projection you say please always follow center of the core, so it will always be in the center of the element. Again, as moving, you will see that actually in most of the cases I'm using all of the properties. So that's again something I really want to stress, that you don't need to go to the part which I specified before, Analytical Adjust. You actually can do most of the modifications using the properties, and then once you do it through properties, you know that will always follow. So basically it will be updated. One more small example, and sometimes it just happens when you place a column, when you place a foundation, then you make your column longer with an extrusion, you will have a gap. For example, the analytical line will stick to where it was. So what you can do, again, selecting analytical line, and in this case saying, for example, base extension, please use a projection, and let's use bottom of the column as a projection. So basically it will always follow the bottom of the column, or the level, or reference plane which is named, and etc. So you have lots of possibilities there. Wall to the column, again, maybe I'll show it that way. In this specific situation, again, you don't have much possibilities to modify where the wall should go. So what you need to do, you need to go to Analytical Adjust, and here you have a tool which is called Wall Adjustment. So basically you select the line and then you select where it should go, and it automatically moves the analytical line of the wall. So far the walls are most static element in Revit. Yeah, again, I have these nodes, and this functionality is coming sort of to say that probably it will be modified the same way as the slabs. And when it comes to the slabs, I can show it that way. You will see that when you select a slab, it actually has the grip symbols as well. So basically I can use the grips, the nodes. The slab is staying in the same place. I cannot extract it outside, so that's a security reasons, and very nice that we have those. But you can drag it in and out. And in addition to that, you have really nice function which is controlling the openings. So you can say always when it has in contour, additional contour, you can always say if this is an opening or if it's not an opening. So again, it otherwise it will neglect the whole opening. I'll get back to that a little bit later as well. So getting back to our elements. This is again something which is quite common situation when you have your slab and when you have your beams, and basically you will have some kind of a distance here. So it depends always from this distance, but sometimes it might be that actually the distance will be very small and the finite element mesh will be very dense here. So in that case, this is something you want to avoid again, because you will have a huge finite elements here and then very dense here, so it will be problems when meshing the whole structure. What you can do regarding that, again, you can always think of it as this distance is important for you, and maybe it's not. So then you have several possibilities. One of the possibilities would be that you can select the element, and once you select the slab, you can go to edit boundary mode, where you have all of the lines, and for that boundaries you can select it, and you can say, for example, is it going as a projection or as an auto detect? So projection will always follow the slab edge, whereas auto detect will always jump automatically to the line. So if I would move back here, you see that now I changed the element. So basically you can even control this when you draw the slab itself. When you are in the sketch mode saying, will these lines for analytical model be auto detect, or will it follow the edge of the slab? As well, you can do it a little bit later when you have it. You can select just analytical model, and when you select it, you have possibilities here, which is saying auto detect or projection. And again, you can control it by every separate line, for example, using tab to select a separate line, and then I can say it for one line, is it a projection or is it something else? And if it's projection, where is it? What I can do more here, going back to my reference plane, to my level, create one more reference plane, for example, somewhere here, in case if you have some specific situation. And once I give name to the reference plane, I can use it later on. So let's say if I name it somehow like that, AAA, and if I go back to my model, then I click on this specific line, and I specify that actually this should be a reference plane which is called AAA. You will see that it automatically jumps to it. So basically you can control where the element is. The same workflow you can use when you want to, for example, angle your slab when it's a little bit tilted. By default, your whole analytical model will be lying in one plane. You have alignment method. So you can use a projection, and instead of top of a slab or something, you can use named reference planes as well here. So that's other possibility of sort of specifying where you would like to have your slab in a horizontal plane aligned. Moving a little bit further, again, this is something which I'm not going into much details, but sorry, I need to go to analytical model. So we have a column here, we have a analytical line in the middle of it. So if I go to the properties, I will have possibility, for example, to specify my top alignment of the element to a projection, and saying, for example, that Y direction should be a reference plane. I have this reference plane which I named ref plane. So you see that analytical line jumps there. So basically I should need to do the same for base alignment projection and then AAA. Sorry, that was the wrong one. Ref plane. Yeah. So then the analytical line moves here. And basically the good part about it is that actually it will stick with it. So once I have it there, if I will, I have it locked probably, let's try that way. Let's move the reference plane. You will see that it's actually following the reference plane if I move my reference plane, so you can lock multiple elements to the reference planes. And again, the same way it works, exactly the same way it works with the grids. So I can use existing grids here by saying, for example, that top alignment is projection and X direction, it should be a grid B. So then you see that the top jumps there, and then again the bottom. That's wrong. Projection. That was the X direction. I was trying to choose different directions. So then you see that it actually jumps to the grid. So you can control this as well just by clicking on elements, properties, and specifying where it should go. And if in a way you modified something and then you don't really get why this happened, for example, you want to have an easy way of fixing it. By selecting the analytical line, you can always choose the analytical adjust, selecting it once more again, and you will have option which is called Analytical Reset. So when you click on this Analytical Reset, it actually recalculates where by default your element should actually be. So Analytical Reset will jump automatically into it. So in many cases when I have some issues with Analytical Model, it's actually enough just to go to Analyze, Analytical Adjust, select the analytical line, and use this option which is called Analytical Reset. So it automatically recalculates the place of the analytical line and places it there. So that's a fast and easy way of doing it. One of the last examples here is actually this one. In some cases you might have something like that. Beams, elements, and then again how they should actually join. Maybe you should want to have additional moment here. So by selecting the analytical line, you have two options. One of the options would be saying that this analytical link is yes. And for example, the other option would be saying that the analytical link is actually reading it from column. So basically in the column you have additional parameter which is saying that's the wrong one, analytical column here, which is saying one more time I selected something wrong. Now I have it. Very good. Here, which is saying analytical links. So when you click on it, then the column is allowing analytical links. So basically, if the beam has a property from column, it sort of reads the data, and if column allows rigid links, then it does it. In the other way is actually if you have some kind of a gap between elements or some inaccuracies. In 2013, you got a new option. Again, under the Analytical Adjust, you have an option which is called Analytical Links. So basically, I can click on Elements, on Nodes, and it will generate this line automatically for me without going into the properties and specifying it that hard way. So basically, I can join any free gaps if I know that they should be joined, and it will generate a rigid link in Robot for you automatically. So getting back to the model, these are the most sort of used functions which you can use on a daily basis, going into the elements and specifying some properties in order to align the analytical model correctly. As I said as well, you have an option here under the Analytical Adjust to do it in kind of a easier way in many cases. But I would recommend using it as sort of a last resort when you cannot generate your model using all of the properties. You can go here. So in this Analytical Adjust, you have possibility to move all of the elements where you want. As I said, use the align tools, for example, to align the elements. For example, like this, one to each other, and etc. specify separate element nodes and just drag them around. That's really powerful tools, Analytical Reset, using walls and so on, which allows you to modify your model. And again, it's as free as it never was before, because earlier you had just part of the options I've showed you going for properties. Now, in any case, if something is not achievable, you can always do it with this Analytical Adjust mode. A little bit more about the Analyze tab and the things you have here. So one of the things you will see is actually that you have possibility to create loads, load cases and combinations. So basically, first of all, you assign the load cases, which kind of loads you have. So that's pretty easy to do, just selecting which kind of a load you want to have. So if you don't want one, you can delete one. If you want add one, you can do that as well. Load combinations. Basically, when you have defined your loads, you can define a new combination. For example, I'm not specifying a name, just saying that this combination will be made from dead load, live load, and then maybe snow, and then maybe something else like wind, and then I'm specifying the factors manually. 15 is a bit too much for dead load, don't you think so? So 1.5, specify a number, for example. So that's the way how you compose the combination. And the way how you add the load itself is actually, again, fairly simple. Just clicking on loads, and then you have several different types. So point, line, and area load, and then hosted loads, point, line, and area. So all of these loads here, they're actually sort of based on the coordinate, where you place them. And this might be kind of a dangerous, because if you move your elements, it might be that it's not applied to the element anymore. Well, if you choose this one, hosted load, then it will actually apply the load for the element itself. So you need to have an analytical element, and when you click on it, it will apply the load to it. So basically, when you move the analytical model, it will always follow the element. The most asked question actually about these loads is where should we generate them? So my recommendation again for this is simple. If you do the analysis just in Robot, I would prefer doing the loads and load combinations in Robot, because it has more possibilities, more functionality there. It has possibility to generate automatic combinations, so it's way faster to do it. But in the same moment, it might be some situations, for example, when you want to use other analysis tools. Let's say in your company work several people, and it might be that somebody is using other tools. And again, from Revit, most of the analysis tools actually they have their own links. So then it would be beneficial of having all of the loads already there, so that he can do his part, or for example, recalculations after a while of the same model if needed in other software. So then all of the loads are there. You don't need to duplicate the work. And again, you might need to add loads if you want to use some of the extensions. You know that you have possibility to do analysis in the cloud, which takes the whole model into the cloud and analyzes it there. Or that you can go to extensions, and you will find, by the way, extensions is accessible through the subscription. You will find quite a bit of analysis tools. Again, it's just simple static analysis, but then you need to have loads applied. So in these cases, you would need to apply the loads in Revit. Going back to the Analyze tab, boundary conditions. Again, this is basically just supports. You have a line, area, and point support, which is fixed or user-defined or pin, etc. So basically, when you place a support, you need to place it on the node element, and it will actually apply the support. And then you have some checks, which is consistency check and check for support. So basically, when you check for support, it says if some elements are unsupported, and when you use the consistency check, it checks whether your analytical line is outside of the contour. For example, like I have here, this is my beam, but the analytical line is on top of here. So basically, this distance between the analytical line and the physical model, there is a gap. And under these analytical model tools, if I click this small arrow here, you have analytical model settings, or if I move to the manage and structural settings, basically I will access the same thing. You have some tolerances. So basically, again, this is, for example, one of the things here, which is called analytical to physical model distance. So if this distance is specified to 150, and if you have a larger gap between the actual model and the analytical line, it will issue a warning. So basically, if I go to analyze, consistency check, distance is larger, then I click on the list, and then it shows which exact elements are larger. So I have something for walls. Do I have something for beams? For example, just say show. So then it says that there is a distance between these elements and etc. So when you select the different element, it actually highlights the element in the view. Like here, for example, the column ends here, but the analytical line is still continuing. So is it correct or not? What I can say about all of these settings, first of all, I don't use the automatic checks because it's sort of time consuming. Every time you do something, it checks for this consistency and starts popping up you warnings, maybe in the case where you don't really need it. And then other thing is actually that I usually do prefer doing all of the checking in Robot. So basically just sending whole model there, meshing it, analyzing, looking at the deflections, displacements, and then I know directly if all of the elements are connected to each other, and then I know if all of the elements works the way it should work. There is one more thing here which I want to specify, is this horizontal and vertical auto detect. So basically when I clicked on this element, and when I specified that please use alignment method auto detect, and it automatically jumped to the element. This is actually because of this distance between those two elements were smaller than the value specified here for horizontal detect. If the value would be specified here smaller, if I would have 10 millimeters, and the gap would be bigger, then it will not automatically jump when I use auto detect mode. So basically this is the settings again which controls that. So that's pretty much about all of the analytical model in Revit. Again, how you can control it and how can you make a more accurate model. Uh, in general, most of the model actually is being done quite okay from the first time automatically with Robot. Uh, but again, sometimes you just need to do this analytical adjustment. So basically, it's always with every project a little part which you need to uh, do manually. And again, it's always easier if you have this control from the very beginning of the project. If you, in very end, when the whole structure is modeled, if you have the model where nobody looked at an analytical model, and you need to do the analysis the same day, you expect having a Revit model and do the analysis the same day just because you have this analytical model and this wonderful integration. Well, that might not just work, because then you need to put a lot of effort into closing all of these small gaps and etc. Fixing all of the analytical model. So it's always easier if person who's modeling that he has a focus on the analytical model and does it from the start, does it correctly. Then it's way easier to control the whole workflow. Yeah, getting back to the PowerPoint. So next point would be interoperability. So sending model to Robot from Revit and back and forth. So basically we'll talk about limitations or functionality. I call it that way because again there is some functions where somebody is saying that it's limitation, but actually this depends from the point of view. In many cases this is actually intended functionality. We'll talk about the element update and etc. Section mapping, what happens to materials and which data is added in Robot, what happens to it later on, and what happens when you do the second and the following iterations. So when you send the model all the way around. one more time, let's take a look at that. So getting back to my Revit model, closing this one, and going to this small example here. This is a very simple house model which I use many years already. It has all of the necessary elements like walls, slabs, beams, and yeah, steel elements and concrete. So I really like this for the presentations. It really shows the purpose of the whole presentation. So, and as well as light. One more thing which is really nice in 2013 version is actually that you have these buttons here where you can select and deselect the analytical model very fast way, so you don't need basically to have a separate analytical views. And then you can show the temporary analytical model, enable and disable it. So basically it shows only analytical model hiding the geometry. In this moment, actually, what would be really useful is having a little bit more control over what is start, what is end of the element, and etc. Because these things might be important when you go to the robot, to analysis part, or when you apply the loads, for example, when you say that the load should be located at the start of the element. So in 2013, it was implemented a feature. If you go to visibility graphics, under the analytical model categories, by the way, the analytical model, it has its own categories now, so you don't need to go there somewhere, find a column, and then find somewhere analytical line there. It has its own categories now, so what should be shown. And if I move to the object styles, for example, for analytical beams, you see that it has start and end segments, which can be colored in a different way. So if I would go to structural settings, here, analytical model, you have this option here, which is differentiate end of liner analytical elements, but nothing happens. And nothing happens if you have created your model in 2012 or previous versions. So basically, this is a new functionality. So you basically need to go to visibility graphics and re-specify the object settings, or use the other workflow, which I really appreciate more. So basically what I do when I have the model which I updated and I want to get all of the information, I just open a new project. So using the standard template, for example, a structural one. Getting back to my model, and I'm using transfer project standards. Checking none, and selecting object styles and clicking on OK. So then I say, please override existing object styles. One more time, check none. It should be object styles as far as I remember. Okay, maybe I need to do one more thing, but I don't think so. This one. Yeah. So I have this, visibility graphics. Give me one more second. I need to go to my structural settings, check if I have differentiation. Okay. So then it means that it's a little bit more than in one place. Let's do it easy way. I will just select everything now. Click on OK and override all of the settings in order not to check which specific option, but basically you can do that. You can just specify what exactly you want to update, and then only specific parts will be updated. But as you see in this case now, I have updated everything basically. So all of the visibility comes directly into my model. So I have all of the start and ends with the different colors, and then the walls and slabs are actually having the surface which is filled. And again, this is really nice way of displaying and looking at your model. If I would go to analyze and analytical adjust, for example, in this case, select the opening option. One more setting, analytical adjust. Okay, theoretically I should be able to click on the mid box here and specify is this an opening or not, so that it would automatically be readjusted. I can go back to this model, fast forward, just modeling something here, edit a sketch in the middle of the element, moving to back to my temporary view, Analytical Adjust, selecting openings, and great, it's not working. Okay, that's the beauty of the live demos. Usually in everyday life it really works. And just by clicking on this element you will have a tick box in the middle where you can specify should the element be an opening or not, and then again it's a really easy way of deselecting the data. So I'm getting back here, I don't need that actually opening, so I will get rid of it. Looking at my model, and what you will notice that I will actually have some load cases defined. So I have some snow loads, I have some wind loads, and I have some surface load. And in general, I see that my model is kind of a prepared here. So if I go back to my model again, I can start integration with Robot. So going to this part, again, in order to get this button, you need to have the extensions installed. So once you have the extensions installed, you will get this analysis and code check button. And then we select robot structural analysis link. Once you have it there, you say send model. And when you send your model, it's always wise to go to this send options. When we move there, you need to specify for which load case you want to apply the self weight. So usually it's dead load. Bar end releases, I usually prefer not use Revit settings. Again, it depends from which templates you're using, but in many cases, I've seen that many times, every time when you create an element, actually analytical line has moments released in the ends of the elements by default on all of them. So it's not all of the situation always. So sometimes you don't want it, and I like to have a little bit more control. So if I want to have a release, I want to add it in Robot. So I'm not using Revit settings. And additional settings, which is again possibilities to specify materials. Curtain walls, I don't care too much about them, and usually I don't transfer any of these, at least the first integration. But the material is something you really need to be worried about, and it always depends from what kind of materials you have in Revit. Are they good enough or not? I had it several times that you send the model to Robot, you start analysis, and then you see that it acts really strange, and then you actually find some elements which has basically no stiffness due to the material properties, so which were incorrect, and then the whole wall, for example, was working like a sponge, so the whole element was deflecting the wrong way. So in many cases, I use either this one, so select best matching or default materials, if I don't trust the materials from Revit. If you select this one, the new materials will be generated with Revit settings. And then this part again becomes kind of important, because if you look at these materials in Revit, let's do that actually. If I would select some kind of an element here, like slab, edit, structure type by category, so the concrete will be selected, I guess. For example, let's choose something like this one. This is kind of a standard elements which I have: concrete, cast in place concrete, B25. Again, this was from the previous versions, 2012. First of all, the name is too long. So when you have this long name and you create this name in Revit, basically only the first part will be created. So if I will have several different strengths of the materials, for example, this one, and then be something else, all of them will have in Robot one name, and basically one of those, usually the first one, physical properties will be used. So basically all of your elements will get the same material. So that's kind of a scary thing. Other scary thing, which is really scary, is actually all of the properties, physical properties. For example, for a concrete B25, you have a concrete compression strength which is 30. And it's just one value you have. But if you go to robot, and if you go to robot materials, you will see that, for example, modification and concrete, that's interesting type of concrete. Yeah, for example, B2530 or C2530, that's exactly the same. You will see that it has two values, and it has cylindrical and it has cubical strength. So it always depends from which database you actually have. And it might happen that in your database, the default setting will be standing as a cylindrical strength. So basically, when you will send your material from Revit to Robot, it will be created as a new one, and in this case B25 would be created with a concrete compression strength 30, which would be a cylindrical strength. So then again, the calculations wouldn't be exactly right. So this is something you really need to think about, and you really need to cross-check the materials. So going back to this, analyze, robot link, send options, additional options, maybe use default, maybe select best matching properties. So again, it's up to you. I will use for this demo as default materials. So sending OK. And before I click OK, I want to explain this one. I have quite often questions sort of shouldn't I use it, or why should I use it, and so on. So in general, the answer would be probably when you don't have a robot license. For example, if a person who's doing the modeling in Revit, if he doesn't have a robot license installed, he can use this one to send model to robot file and to update the model from robot file. What he will need to do though, he will need to have robot installed. No license is needed, but robot needs to be installed, otherwise it will not work. But if you have robot installed and no license specified there, it still will generate the RTD file, which you later on can share with the colleague who has robot installed. So clicking on OK. I don't want to save any files. File not saved. That's great news. I think I need to do this, and file. Close the project at least. Usually it does it automatically. So one more time here. Send model options, just checking them, and OK. So after the first send, it will remember automatically my used settings. So next time it will be already all right there. So usually it's pretty fast. Warnings have been reported. Yes, show me the warnings. Do not care about the message. Regional settings are not set to the United States. So basically what it does, it gives me a warning saying that my robot structural settings are not the same as the extension settings. And if I go to the extensions, under preferences, you will be able to specify regional settings. So basically from that depends databases you use and some other things. So again, it might be an issue to profile mapping. What happens if you don't have a profile actually here? During this integration, you will have a pop-up window where you need to say, okay, this section was not recognized. What do you want to use instead? So you have a section mapping possibilities. And again, you can do some manual mapping if you want through the file. So now the whole model was centered here. So all of the loads should have traveled together. So dead load, live load, with all of the values, wind load, snow load. And then I have some empty load cases, which I actually sent from Revit, but I haven't applied anything to them yet. So I can go to, for example, this load types, and I can get rid of all of the ones which I don't need in Robot. Delete this one, and maybe delete this one. Next step would be maybe loads and automatic combinations. Again, the purpose of this demonstration is not to show robot in detail, so I'm not spending much time there, just fast forward doing the things I usually do. So just creating some definitions. It gives me some warnings about that definitions were changed, so I will just Respecify that. It usually happens when you change the standard, so that might happen. Okay, no warnings now. So my element was meshed. So first of all, what I do when I calculate a structure, I look at the mesh. If the mesh is correct, if there is some inaccuracies. So if I have a proper mesh, I know that everything is fine. What might happen in many cases, again, if you have some kind of a beam specified somewhere, and then you have a column slightly offset from the beam, like some centimeters or millimeters even, it might cause inaccuracy, so sort of the finite elements just goes bananas in that place. So have my model, have all of the loads, have the combinations, I have calculated it. So what you can do in this model, let's say I will just jump fast forward through calculations, for example, of concrete elements. So just going there, saying that I will use all of these loads, running calculations. Reinforcement, column node, small drawing, everything I need here is there. So geometry, jumping back, selecting the beam and doing the same here, doing the calculations for the beam. So just calculate, check the reinforcement in the element without even going into the properties, just using the standard values. Of course, not something you really do, but just fast forward. So now I have calculated some elements. Let's do a little bit more. Let's actually change my geometry. So for example, I will modify my elements. So I will just move one of the beams downwards. Recalculate the whole structure, of course. And let's move, for example, to steel design, steel aluminum design, and maybe create a new group specifying some member numbers. For example, these columns should be the group, and for that group I would like to choose from HEAB profiles and optimize that group by weight. Run the calculations. HA100 is optimum one, change all to quite smaller profiles. So the profiles are updated. Recalculate it again. And probably I'll go to a steel connection design, for example, just showing that you have these possibilities as well. Specifying, for example, one connection here, saying please do the automatic connection. Let's use maybe other part here, this one. Automatic one as well, and then plate brackets with brackets, apply OK, and run the calculations. So it will give me just some ratio. So, but in general, what I need, I just want to have some kind of a connection here. So now I have it. So getting back to my geometry. So now what I've done, I've modified my model a bit. I have changed some profiles. And what I will do more, I will add, probably I will add additional loads. For example, I will say load definition. And I will specify a bar load, which is, for example, temperature load. And I will add it here. So if I look at it, okay, I need to look at the snow value. That's interesting. Here, you see that I have a temperature load. Just for sakes of clarity, I can add it on the element which didn't have it. So two elements have a load which you don't have in Revit. And then maybe something else. Maybe I will add additional element which is a cladding, which you again don't have in Revit. So for example, rectangular element from here to here to here. So now I have updated my model with adding some data on top of it, adding some elements, and I can add even additional surface load, for example. on this cladding I have created. So of course my model is changed now. I will just recalculate it. Just pay attention to that. I never saved the file anywhere. Actually, you should do that. You should save it somewhere. So what I will do now, I will go back to Revit and I will actually import the file. So going to Analyze, Analysis link, Update, and for update options now I can specify what do I want to update. For example, update the whole project. For example, import the reinforcement and steel connections. You can import even required reinforcement if you wish, but let's say just do these graphical changes and OK. So the update will take some time because I requested for reinforcement to be generated, and that's basically taking most of the time when it comes to general section dimensioning and so on. It usually is way more fast forward. What you can see already in the model actually is this analytical line. You see that it jumped the same way as we have modified it in the robot, and that's actually a very nice way of doing it. Many people are actually kind of afraid of messing up the geometry. They're afraid of screwing the structural geometrical model. And updates have been reported. Let's check at that. Again, warnings. Analytical distance, I don't care about that. So many people are afraid of messing up the analytical model, but actually you see what happens when you in robot add a new data. For example, if I would add a new beam, this beam would be imported into Revit. But if I modify something existing, for example, if I modify already existing element, just move a slab slightly or move a beam slightly somewhere, it actually updates just analytical model. So your geometry stays intact actually. The geometry is where it is. Of course, you will get this warning for coordination that the elements have a distance now bigger than something. But in general, your geometry is staying there where it was, and only the analytical model is being updated. I find this very useful, and actually, again, not limitation, but a functionality. Because if you want to do some changes to your geometry, do changes to geometry in Revit. Don't do the changes in Robot and expect it to get back. For example, if you want to add an opening, you don't do it in Robot. You do it in Revit, communicate with other parts, architects, MEP engineers, and etc., and then send it to Robot to analyze it, not adding it in Robot and sending it back. So again, this is a small sort of thing of the way how you think and what the workflow should be. As you see, some steel connections have been imported. Of course, it's just what you have available in extensions. So it's basically just 2 steel connections which can be imported. But still, it has possibility to do that, as well as it has possibility to import the reinforcement backwards. Again, you don't see the elements which cannot be created in Revit. So you don't see the cladding and you don't see the temperature loads because you don't have a temperature loads in Revit. So let's do one thing now. I haven't saved the file anywhere, so what I will do, I will just close it now. Go back to Revit, and let's say you've done some modifications. Let's say you actually added some more elements or maybe modify them. Let's try doing something here. So if I will go to beam, let's try 3D snapping. I hope I will catch it on the right place somewhere. Let's say I have added one beam, just theoretically speaking. So I have updated my model. Going back to analysis, robot link, and sending model again. Now it remembers my previously used settings. I don't want to these reinforcement and projects and steel connections. So let's please do that now. Send it back to robot. So now the new file will be generated, And actually what will happen, in one point, it will merge the files. So basically, during this procedure, when you update your Revit file, actually Revit creates a copy of the robot file you had. If you go to manage part and if you go to project parameters, project information, you will see that you have here a rem linked file name. So basically it's hidden or placed just in app data roaming, whatever, additional file. So even if you don't have the file which is actually saved on your desktop, Revit does it for you. So basically this data is now in Revit. So after this integration, of course, don't forget saving your Revit files as well, because this is important as Revit remembers where the data is. So when next time I send it, all of the new changes will be taken from Revit, and all of the things I had previously will be actually merged into the project. So if I would go, for example, to my steel design and connections, you will still see that I have these two connection types. Of course, results out of data, but still I have the connections. If I go back to my structured geometry, and if I look at my loads, that was a snow load, I believe, you will see that I have the temperature loads I have applied. I have a cladding, and the geometry is where it was modified. So basically all of the data, even the mesh, finite element mesh, will be there because it takes the missing data from your previous integration files, which was stored there. So from here comes a very important part of the whole integration, that you need always to update the file. So once you send the model to robot, you need to update it back and save your Revit file, just in order to make a full circle so that Revit knows what was done in robot, which changes were done there, and etc. So you need to do this integration in a full circles. And the good thing about it is that the data is actually kept there, so you will get all of the data for further work. Again, that's pretty much about the integration. We'll leave the questions in the end of the session. We have some time left, and then we have a few more topics, or just one, I guess. If I go back to the slideshow, and let's talk about extensions. So you have some different extensions which you can use to generate the model, both in Revit, in Robot, but mostly we will be focusing on extensions for Robot. So again, let's look at those. What I will start from is actually I will start from Revit. Again, all of the extensions which I have here, they're actually accessed through the subscription center, so all of you should have access to it. If I will move here somewhere to modeling, you will see that I have a frame generator, one of the extensions. If I select that frame generator, it's for steel frame structures. You will see that you have possibilities to generate it. You specify the geometry, you specify the slabs, you specify the bracings, what kind of elements you have there, and then you just click on OK, so the structure is being generated. What you have as well is that not only this menu here in Revit, of course you could create it in Revit and send it to Robot, but you have the same generator actually in Robot as well. If I will just close this file and open a new one, just clicking on Shell Design, for example. Under Add-ins tab, you will see that you have this frame generator also. So when you click on it, you will have nearly the same interface where you can even open the file that you had from Revit, save it as a standard default settings. Again, number of frames and spacings and how it should be used, and then the geometry, how the roof should look like. Is it double or single pitch? Do you want to have a truss instead of a bar, or should it be a simple bar? Additional decks, if you use any brackets, and then bracing, just clicking on the different types and in different places. outer walls, for example, you can specify different type of outer walls in the structure. And one really nice part, which is here, is actually the loads. So where you can say that you want to use that loads, for example, crane load if you wish. And then you can even use the snow wind loads from settings. You know that the robot has possibility to calculate according to the Eurocode with national annexes. All of the loads for you automatically, dependent from the snow and wind zones and permeability and etc. terrain type which you specify. So in general, I have possibility to go to documentation and then calculations and design, but let's just click on OK first, just to generate the structure. So what you will see is the structure generated. So you can see here that the structure was generated pretty fast and easy way. And if you look at all of the loads, you will see that loads were applied to the roof elements, to the wall elements, and then again, it's not just one kind of a load, it applies really different type of combinations. So wind from one direction, other direction, and etc. And for example, when I will move to this node, one direction, other direction, it would evaluate even the snow pockets and things like that. And for example, even the crane load, which gives an indication of sort of where the load could be, in which positions, which worst cases, and so on. So that's pretty nice functionality again, which you can use in order to generate the model together with all of the data in it. One more thing, if we talk about Revit, is actually a really nice way of modeling the structures using a structure generator. Again, this is not really common way for structural engineers to think, but usually architects they start their modeling from masses. So in the beginning they have just some kind of a mass, which later on they actually detail. So what you have as a possibility is actually to generate a mass and add structural elements to that mass. So if I will not go through it in details, just opening a small example. So new conceptual mass, for example, I will select a new template, and then just I will show part of the workflow sort of is to generate some kind of a model. For example, create a form, one more model, create one more form here, let's say, which is straight. It's obviously, you will see the reasons why I'm not an architect, not really architectural structure here. Let's make it a little bit more architectural by tilting one end. So let's say you have some kind of a structure, for example, like that. Once you have this structure as a mass, of course you can save it as a family load into the project. What I can do more with it, I can divide all of the surfaces, and once the surfaces are divided, I can specify the different pattern of the surface. So for example, rectangular pattern. So I will get something like this in the end. And once you have that kind of a structure, of course, it would be best if it would match with the elements. In that case, can I just leave it that way as it is. So we'll not bother about it. If I select now the whole structure, I can do it, I believe, straight in the family, going to extensions, model, and then structure generator. Whole project, let's do it for the whole project here. You will see that the model was interpreted here, where basically I can select the structure as a separate element. So let's say selection. For example, select, I don't know, this roof. When the roof is selected, you can generate the structural elements. Let's try based on model. Okay, I jump to the different menu now. So then in general, what it should do, it should generate, let me go to the 2D view, it should generate the structural elements instead of the elements I have selected. So you can basically select again which element should be generated. Do you want to have these perpendicular columns? What for the beams? Which element should be generated? So in the end, you will be able to create a structure. And what's nice about it is that you can actually create it in Revit or Robot. So if you select a Robot and generate, it will be automatically pushed into Robot. So you can do the analysis. So basically, you can really utilize this for early stage analysis of the structure. If you click on Help File, I believe somewhere here there should be some examples here, some examples of the structures which you can sort of achieve and what you can do with this generator. Again, don't think it about as about a detailed analysis tool, but for example, a situation like this is a really nice way of having some kind of a shapes which would be quite hard to simulate. So we can add our trusses as well. Dependent from the geometry, fast forward generate with this tool. So basically you modify the math and the geometry is being changed automatically to that. So you can do the fast analysis, update your structure, and etc. So really nice one. And pushing things a little bit further, all of you, when you install the robot, you have possibility to install the spreadsheet calculator. If I go here, Robot extension spreadsheet calculator, you should be able to access it from here as well by clicking add-in and spreadsheet calculator. So this is actually the Excel based application which has integration with Robot. So if you look at it, it has lots of different things. For example, if we talk about timber structure, it will have possibility to calculate some kind of a timber connections. For example, nailed connection. What you can do, you can read from Robot. So basically, it has integration. You can read some forces from Robot and etc. It has a pre-stressed structures, some simple static analysis, and some other really nice features. So basically, it's just an Excel sheet, which is of course locked. So you have possibility to interact with Robot back and forth. And for example, if I would go to Robot and modeling here, you have several simple examples of what you could do with it. So in this case, for example, I can select something which is called, for example, frame made of sections of variable interior. So where I can specify what elements I have, which width I have, how the element should look like, and etc. So just specify the geometry. And clicking one button here, which is called model generation, and then this model should be generated in Robot. It's usually a very fast procedure, so it's already done. So as you see, the model, the simple frame was generated with all of the varying sections. If I go back to this one, for example, select something else like silo. Again, some specific thing which I could easily create just by clicking model generation. The model has been generated, so it gives me information about that. And you have a silo which was there. As well, if I go back to this one, I have something else, I believe, which is called, for example, a tower. Again, a simple geometry where you can specify, for example, what is the base, what is the height of the element, to how many parts it should be divided, and again, generate a simple model. Still generating, or yeah, for example, like that. Again, you can apply some sections to it, but what it does, it just creates a simple geometry. So basically, using these tools, not only the ones which are predefined, but under add-ins, you will have possibility to create your new sheets where you can add additional, for example, insert some formulas or insert some kind of parameters. where you can say, for example, please read the geometry from robot and, for example, node info, whereas for node info you will use a coordinate or something like that. And basically with a integration from robot, from the file which is open, you can take the data in, post-process it, or you can push the data out and post-process it. Again, there is in YouTube, there is quite a bit of videos about it, and some help files of how you can do that. The whole sort of purpose of it is that it should be easily done by engineers not having a programming experience. So that would be the last resort. So sort of if you have some kind of a structures which you're doing often, which is the same geometry from time to time, you can actually just generate a spreadsheet in this robot extensions. One thing which you need to know, again, you will need to go to a subscription center and you need to download the content. So basically all of the library which I showed here with all of these different elements, it's downloadable from this the subscription center as an additional content. So once you do that, you will have all of the sheets predefined here. So check it out, it's a really nice feature. So yeah, time for questions. So please use the chat window. I will try to answer all of the questions which I will see there. Any questions, guys? I see people are leaving instead of asking questions already, so I know that it's lunchtime, at least in Norway, so anyway, guys, I see that yeah, Jonas, I got the feedback that it's a lunchtime in Denmark too, so okay, guys, let's send it there then. If I move to this one, have last slide, which is saying that this is the end, and actually one more, basically saying thank you for attending this session. In the corner here, you see my email. Basically, I send all of the invitations from my inbox. So if you will have any questions after that, just drop me an email and I will try to help you guys. Okay, thank you, and have a great Christmas and New Year. One question here, have the session been recorded? The answer is yes, the session have been recorded. Again, drop me an email if you want to have a link to it. Probably I will upload it somewhere to YouTube or distribute it in any other way. I have one question from Jonas about trust generator. Okay, and one more. Okay, special for you, Jonas. getting back to Revit and getting back to my standard model. That will be fairly simple to explain it. Columns, let's do 2 I-beams, and then I will just do 1 beam in between. So which connections? If I would select now these kind of elements, here I have a beam, then I have a column, and if I go to extensions, I have 2 types of connections. So it's beam to column, end plate, and column base. So in this case, if I would use this, for example, column base, this would work. Give it a second and it loads API. So basically I can say what type of, again, it's kind of similar to Robot, where you can specify, for example, stiffeners, what kind of a stiffeners you want to use, and etc. So this is a base connection, one type of it. Other type of connection is column to beam, but then again, you need to, sorry for that, I'm just jumping in between and out in windows. Oh, that was a big one. Not a pretty one, but big one. Other connection is column to beam. But then again, what you need to sort of be aware of is that if I have it as an end plate, as I do have it now, extensions, tools, steel connections, beam to end plate, it works. So it can generate a simple fast forward connection. And it does it, doesn't it? Yes, it does. Of course, it's colors just because of the materials. But it's enough to have my element rotated like that. And it will stop working. Geometry is not correct. So basically, it's pretty limited to 2 type of connection style. So base element and then beam to column end plated. Yeah, very limited. What about the question about the truss generator? Have you wondered about the truss generator in Robot? Yeah. So you have possibility to, I'll just close the project here and start a simple, let's say, frame 2D design. You have some standard databases here in Robot. So if I will create, for example, 2 columns with some kind of a gap in between, for example, nobody cares about how pretty it is as long as it works. So selecting this one, typical structures and a typical structure database, you have several options here with the trusses, and then you have a library typical structures somewhere below here. So different type of a trusses, and then you have some plates and shells. So basically you can use this. In general, I use it just for trusses in a way. So when you enter the dialog box here, you can specify which truss you want, and you see the sort of ghost images behind. So basically it means that you can achieve that kind of a truss shape using this button. So what you need to do, you need to select type of the truss you want, click on OK, and then start specifying it. So for example, first diagonal up or down. Then you click on the length, which you can specify directly in the screen. Click on apply, then it shows the length. Then you say height, for example, 1 meter, number of fields, 11, apply. Continuous short, moments released. No, I don't want to have moments released. And then maybe distance, 0.5. For specifying the middle part, I can uplift one end, and then the important part is actually with the trusses is the sections. Because by default it uses the standard, I believe it's either American either British database profiles. And if you click on it here, it issues the warning that the section was not found. But if you click on OK before specifying the proper sections, it will actually generate nothing. So that's the problem. So usually what you do, you just click on these dots and you specify what kind of a section you want to use. What I can do as well is Control C and then Control V to copy the same section, or you can type it in, for example, HEA 100. That works as well. And when you go to the insert, in this point, you need to specify the insertion point. Again, apply to check it. So apply, you can click as long as much as you wish. And then you have, again, all of the options, for example, to specify the different angles if you wish over the truss and so on. So once you have the truss done, you can use the last thing is add it as an object, for example. You can say yes and click on OK. So if you add it as an object, it will sort of be as a grouped element. So basically, I can modify it later on by, for example, making it bigger or smaller as the whole element as it's grouped. You know that in Robot you have this possibility to do it somewhere here. Substructure modification, group objects, and then you have option to explode it. So once you want to use it as a regular element, then you can say edit explode objects, and then every single bar will become as a sort of separate element in the end. So then it will work. One more thing actually, which I haven't showed, but I think it's really nice feature. I thought I will show it during this Revit Robot integration. That's a really nice one, at least for me. I need to go to somewhere more three-dimensional than just this 2D frame. So when you have your grids, one more sort of benefit of using grids. When you have all of the grids, let's say I just add 1, 1, 1, apply, close. Missed something. Yeah. So now I have some kind of a grid, and let's again make it simple. Contour, I will just define some kind of a panel. You have actually possibility to move or modify the grids. So by right clicking above the grid, you have options, object properties. So then what you can say, which direction you want to modify it, for example, X direction, and I want to modify it with 1 meter, so I'll enlarge it by 1 meter. And then if I have this structure modification selected as well, my structure will follow the modification also. So it's not exactly sort of intuitive way. In the end, it just sort of extrudes the element, but in a way, it's really nice. It's really nice feature, I think so. For example, -1, apply again back to the previous one. So additional benefit of having the grids in the model. Yeah, don't see more questions, guys. Thank you for coming. Have a good Christmas and holidays, and drop me an email if you wonder about something that was the topic of today's session. Bye, guys.